Assalamualaikum warahmatullahi wabarakatuh. Okay, my name Dr. Karisma Adhananda Putra. On this occasion, I would like to present about our research and already developed as a community service program in Universitas Muhammadiyah Yogyakarta. And the title of our project is STEM Engagement Through Competition-Driven IoT Robotic Program using ESP32 and MicroPython in upper secondary education. So for the study motivation, competition-driven robotics addresses a persistent state engagement gaps. So the main challenge is upper secondary students face declining STEM interest, especially in Indonesia, and limited hand-on exposure and also barriers created by conventional low-level programming. So prior educational robotic study often isolate robot movement, programming, IoT control, or competition rather than integrating them as one learning experience. So the objective of this study is to develop and evaluate a low-cost, competition-driven IoT robotic framework that combines assembly, MicroPython programming, wireless control, testing, and sumo robot competition. So we integrated this framework and evaluate to 104 students in three upper secondary schools in 4 hours intensive workshop. And the, the framework unifies four components into one experiential learning model. First, we develop educational robots with the sensor and microcontroller and also the actuator. And then we also integrate the the software using MicroPython programming language, and we integrate the IoT wireless control, so the robot can be controlled by using the Android device or iPhone device. And in the end, the student will experience the competition-based uh, activities that evaluate the teamwork, challenge, and motivation. So this is a 7-stage, 240 minutes workshop move student from theory to competition. In the beginning, the theory session about 30 minutes, and then followed by robot assembly, 30 minutes. And then the programming, we already developed the template of the program using the easiest, the advanced programming language right now, which is MicroPython, 40 minutes, and then IoT integration about 30 minutes, and then robot testing 30 minutes, and the competition 60 minutes, and then the evaluation. So this is the main component of our robot, sumo robot, and the ASP32 is chosen. It's chosen for the main controller that react based on the input sensor from photodiode. We have 6 photodiode sensor to detect the the opponent of the sumo robot, and 2 boundary sensor in the bottom, and then we have also the battery, lithium ion, and motor DC motors. And the evaluation, we have deployed this framework to 3 upper educational schools in Yogyakarta, almost 104 students. And we also, for the research instrument, uh, we evaluate the student in the beginning in the pretest, and then after the activities. And this is the technical result for our robot. Our robot platform costs less than 50 US dollar, and this is very affordable for students. And then the response time of our robot is uh, around 21 to 67 milliseconds. And uh, we measure the student knowledge from the pre-test and the post-test. And we have 11.5% increase from the pre-test to the post-test. And the largest gains, almost 10.5%. And for the STEAM engagement, we also measure using 6 questions about the engagement and the 60.2% of interest in STEM higher education achieved by the activities. And for the post score for enjoyable learning, 4.23 in 5 Likert scale. And for the observation gain also, we also measure the question. The evidence support that immediate learning gains, higher STEM engagement, moderate to large practical effect, and acceptable to excellent instrument reliability. So the framework for the conclusion, the competition-driven learning significantly enhanced student conceptual understanding, STEM engagement, and introductory programming literacy, with average learning score increased from 80.9 to 92.4%. And in the technical domain, the proposed ESP32 and MicroPython programming language based IoT education robot platform provide reliable real-time performance and achieving wireless communication response time around 21 to 67 milliseconds. And for the access, with a hardware cost below less than 50 US dollar, the proposed framework offer a practical, scalable, and cost-effective solution for resource-constrained school, supporting broader adoption of inclusive technology-oriented STEM education. And also, it's aligned with Sustainable Development Goal 4 about quality education. So this is for the future study. We will increase the comparative design, longitudinal evidence, and framework extension, for example, using AI integration and scale and transfer, multi-region, diverse school types, and multinational settings. That's it. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.